In the next part of section 2.6, we will talk about radical equations. When the variable in an equation occurs in a radicand, the equation is called a radical equation. Here are the steps to solve radical equations. We will go through these as we do the example problem. So example number 1. If you want to solve this, we have to first isolate the radical, which means get the square root of 2x plus 1 by itself, and we do this by subtracting 3 from each side. So we got the square root of 2x plus 1 equals to 6. Step 2, raise both sides of the equation to the power of the index. Now the index is the root of the radical, but if the root isn't given, we're assuming it's a square root, which means it's a root 2. So we are going to raise both sides to the second power. And what that does is the square root and the square, they undo each other. So we have 2x plus 1 on the left and 6 squared, which is 36 on the right. If we solve this equation, we subtract 1 from both sides. We get 2x equals to 35, divide by 2, and we get x equal to 35 over 2 as our answer. And in set notation form, it'll be 35 over 2. Okay, let's take a look at our next example. We have the square root of 3x minus 5 equals to square root of 2x plus 7. In this case, both sides have a square root, but the steps don't change. Step 1, isolate the square root. So these are both isolated. Step 2, we need to raise both sides to the second power. The inverse of a square root is a square, so to undo the square root, we need to square both sides. And so this gives you 3x minus 5 on the left and 2x plus 7 on the right. Both of the square roots are gone. To solve this problem, we need to move the 2x to the left. So we have x minus 5 equals to 7. Then I add 5 to both sides, and this gives me x equal to 12. Next example, we got the square root of x minus 4 plus 6 equals to x. So step 1, we need to isolate the radical, so we need to subtract 6 from both sides. On the left side, we have the square root of x minus 4, and on the right side, we have x minus 6. To undo a square root, we need to square both sides. So we square the left side and we square the right side. So here's where we have to be careful. Previously, we had a number on the right. So when we squared it, it was just 6 times 6, which is 36. But when we have an expression that's squared, we need to write that expression 2 times. Here's what I mean by that. On the left side, the square root and the square, they undo each other. So we are left with x minus 4. On the right side, we have to write x minus 6 times x minus 6. So we have x minus 4 on the left. On the right side, let's FOIL this. So we have our first terms, x times x, that's x squared. Our outside terms, x times negative 6, that's negative 6x. Our inside terms, negative 6 times x is negative 6x. And then our last terms, negative 6 times negative 6 is 36. So FOIL. And then we need to combine our like terms. So we have negative 6x and negative 6x. So this gives you x squared minus 12x plus 36. Now, anytime we have a quadratic, our first step is to get all terms on one side. Now, which side do you pick? Well, we want to keep the x squared positive. So we're going to take the x and the negative 4 and move them to the right side so the x squared can remain positive. So here's what I'm going to do with that. I am going to subtract x from each side. So if I do that, that gives me negative 4 equals to x squared minus 13x plus 36. Then I need to move the negative 4 to the right. So I'm going to add 4 to each side. Go plus 4 and plus 4. If I do that, I get 0 equals to x squared minus 13x plus 40. Now, I can either use a quadratic formula or factor it, but factoring is always easier. So let's find two numbers which multiply to be 40 and add up to be negative 13. Now, if you can't think of those immediately, that's fine. Let's list all the factors of positive 40. And remember that if a number is positive, then when you multiply two numbers, they either have to be two positives or two negatives. But because the middle term is a negative 13, we're going to have two negatives. So we have negative 1 and negative 40. We have negative 2 and negative 20. 3 doesn't go into 40. We got negative 4 and negative 10. We have negative 5 and negative 8. Now, which of those adds up to be negative 13? That's going to be this combination. So we have 0 equals to x minus 5 times x minus 8. The zero product property tells us that if two terms multiply to be 0, then either x minus 5 must be 0 or x minus 8 must be 0. So if we solve each of these, add 5 to both sides, we get x equal to 5. Add 8 to both sides, we get x equal to 8. Now, more often than not, on radical equations, we will only have one solution. So we need to check these to see which solution is valid and which one is not. And to check, we always go back to the original equation. So first, let's check x equals 5, which means we're going to replace each x with 5 in the original equation. So we have the square root of 5 minus 4, that's your x minus 4, plus 6 equal to x, which is also 5. So 5 minus 4 is 1. We got radical 1 plus 6. We want to check, does that equal to 5? So it's a little question mark. Does it equal to 5? Radical 1 is 1. Now 1 plus 6, does that equal to 5? It actually doesn't. 7 is not equal to 5. So because 7 is not equal to 5, this number x equals 5 is not a valid solution. Now let's check x equals 8, see if that one works. So we have the square root of x minus 4, which is going to be 8 minus 4, plus 6 equals to x. Now remember, x is 8, so we have an 8. 8 minus 4 is 4, so we got radical 4 plus 6. We want to check, does that equal to 8? Radical 4 is 2. Now 2 plus 6 is 8, so 8 does equal to 8. That is true, which means x equals 8 is a valid solution, and in this case, it is our only valid solution. So x equals to 8. All right. Lastly, let's talk about equations that are quadratic in form. So what does that mean? It means that our equation could be turned into a quadratic equation. Like here, it's a degree 4, but we can turn that into a quadratic equation using something called U-Substitution. So step 1, in this equation, here's the important part. Let u equal to the expression whose coefficient is b. Okay, now what does that mean? B is always the middle coefficient. So u is always going to be the expression in the middle. Okay, let me write that on the side and repeat it again. U is always the middle expression. So in this case, u is equal to x squared because u is our middle, x squared is our middle expression, and u is always a middle expression. So u is equal to x squared. Now here's how that helps us. On the side, I'm going to write, if I take x squared and I raise it to the second power, I get x to the fourth. But remember, we said u is equal to x squared. So x squared, which is same thing as u, raised to the second power, that's equal to x to the fourth. Now take a look, our first term is x to the fourth. So what is x to the fourth equal to in terms of u? It's u squared. What does x squared equal to? It's equal to u. So we did something called a U-substitution, where we took the x to the fourth and replaced it with the u squared. We took x squared, replaced it with the u. But before we could do all that, our first step is to let u always equal to the middle expression. And this equation now becomes a quadratic. To solve this, we can either use a quadratic formula or factor it, but anytime factoring is an option, do that, it's easier. So if we factor this, we want to find two numbers which multiply to be positive 18, add up to be negative 11. So those are going to be negative 9 and negative 2, which means u is equal to positive 9 or u is equal to positive 2 by the zero product property. But here's the only problem. Even though we have a solution, we are not quite done because our original variable is the variable x. So we don't want to solve for u, we want to solve for x. In order to do that, we're going to do one more substitution. It's like going in a circle. We said let x to the fourth equal to u squared, let x squared equal to u, but now we're going to take u equals x squared and replace the u with what it equals to in terms of x, which is x squared. So we get x squared equal to 9 or x squared equals to 2. If we square root both sides, we have x equal to plus or minus 3. Remember, anytime you square root a variable, you always get that plus or minus. And the reason for that is because we want to find out which number squared equals to 9. Well, we know that 3 squared equals to 9, but negative 3 squared also equals to 9. So x is equal to 3 or negative 3. So x equals to plus or minus 3. Or, if we square root both sides, then we're going to get x equals plus or minus. Anytime you square root a variable, you get that plus or minus radical 2. So our solutions are going to be plus or minus 3 and plus or minus radical 2. We get 4 solutions because we have a degree 4 equation. Let's take a look at our last example. Once again, this is a quadratic in form, but it's not exactly quadratic because instead of x, we have x minus 4. So let's do a U-substitution. Step 1. What is u equal to? U always equals to the middle expression, which is x minus 4. Now the cool thing is, if we take the x minus 4 and we square that, then we also have to square u because u is equal to x minus 4. So u squared is equal to x minus 4 to the second power, which means this whole thing, x minus 4 squared, that is equal to u squared. X minus 4, that is equal to u. And we have negative 48, and that is equal to 0. We want to find two numbers which multiply to be negative 48, add up to be negative 2. So those are going to be negative 8 and positive 6. Negative 8 times 6 is negative 48. Negative 8 plus 6 is negative 2. And then we have u equals to 8, or, and I'm sorry, I wrote an x. This should be a u. I apologize. Or u equals to negative 6 by the zero product property. But remember, we're not solving for u, we are solving for x. So we're going to take this original u equals to x minus 4 and replace the u with x minus 4. So we get x minus 4 equals to 8 or x minus 4 equal to negative 6 because again, u equals to x minus 4 since x minus 4 is a middle expression. So if we add 4 to both sides, we get x equal to 12. If we add 4 to both sides, we get x equal to negative 2. So our solution set is 12 and negative 2.